Okay, so as we saw, in order to solve this equation, we need to anti-differentiate e to the 5t cosine omega t. How do we anti-differentiate this function? We need to use the integration of parts. The formula for integration of parts is the integral of u dv equals uv minus the integral of u du. The integral of u dv is equal to u times v minus the integral of v du. So all this is saying is, let's take the derivative off of a function and transfer it onto the other function. Here, u is cosine omega t, dv, the derivative function, is e to the 5t dt. That means v is the antiderivative of this function, e to the 5t over t over 5. So if we apply the integration by parts formula to this integral, we get the following. E to the 5t over 5 minus, notice what's du? Du is negative sine omega t times omega. So we end up with the following, minus e to the 5t over 5 times negative sine omega t times omega dt. 5t over 5 plus e to the 5t omega e to the 5t over 5 sine omega t. Now we're going to apply integration of parts formula one more time, but to this integral. And so again, what do? Well, what happens when we anti-differentiate this first factor? It's just omega e to the 5t over 25. Second factor is left alone. It's u times v. And now we subtract. Same thing. But now it's the derivative of this. The derivative of this now is what? It's cosine omega t times omega. So we're left with integral, same thing, omega e to the 5t over 25, but now times omega cosine omega t. Well, okay, well look, we start off with an integral, we end up with an integral, but notice this integral, if we factor out omega, this gets omega squared over 25, we have the exact same integral. So, summarize. Okay. We want to find what this integral is. We have, so this is the unknown. We have a function minus some constant times the unknown. So we can actually I'm going to say a of t, it's an unknown function. Is this integral. You plug it in here, we get a is equal to omega e to the 5t over 25 times sine of omega t minus omega squared all over 25 times a. Let's add omega squared over 25 times a to both sides. We get 1 plus omega squared over 25 times a equals omega e to the 5t over 25. Where A is a function, so that means A of t is omega e to the 5t over 25 all over 1 plus omega squared over 25. Down here, this is just the constant, this is the function. So the point is, this antiderivative is going to be the following. It's going to be omega times e to the 5t sorry, I forgot a sign. So times sine of omega t divided by 25 plus this one. So we break this down. 25 times 1 is 25. 25 times 1 over 25 is just omega times omega squared over 25 is just omega squared. So we're left with the following. We divide both sides by e to the 5t. We are left with I of t is equal to following function. So it's kind of what you would expect if the current is, if the voltage is oscillating 10 times cosine omega t, the current is also going to